Today we will study about the work in physics. Okay, what is work done, and then how to measure the work done by an object. All these kind of things we will study. Work is done on the object or work is done by the object, that also we will see. Okay, what are the conditions to get the maximum work done, and then what are the factors affecting the work. This kind of things we will study in this video. Okay. In physics, work is said to be done when a force displaces an object. So work is equal to, or work done is equal to force times displacement. That means the force should displace an object. Then only we say that work is said to be done. So expressing it mathematically, F dot D, or this is equal to F D cos theta. Okay, now where F is the force and D is the displacement, and then theta is the angle between force and displacement, and W is the work done. Here, force is a vector and displacement is a vector, whereas work is a scalar. I write here force and displacement are vectors, whereas work is a scalar. Here, we are multiplying the force and displacement with a dot, which is called the dot product of vectors. A dot product of vectors always gives a scalar. Okay. So here, force and displacement are vectors, but when we multiply them with a dot, we are getting the work, which is a scalar. Okay. And now we will see what are the how we say that. Now we will see what are the units of work. We measure force in newtons. Force is measured in Newton. You know this one. Okay. And then displacement is measured in meters. And then work is measured in joules. Therefore, 1 joule is equal to 1 Newton times meter. Let us define the joule. When 1 Newton force displaces an object through 1 meter, then we will say that 1 joule of work is said to be done. Okay. Again, I repeat. If 1 Newton force displaces an object through 1 meter, 1 joule of work is said to be done. Hope this helps. Okay. Next, we will see what are the factors affecting the work. So to do the work, there must be some force, and then the force should displace the object, and then the angle should be 0. Because here we are measuring the cos of the angle. Cos 0 is equal to 1, and then cos 30 is equal to 0.8660, whereas cos 45 is equal to 0.7071, whereas cos 60 is equal to 0.5, and then cos 90 is equal to 0. So if you see, as the angle increases, the value of cos decreases. Therefore, lesser the angle, higher the work done. Lesser the angle between the force and displacement. That you should remember, and I will explain that factor later. Okay. Now let us see here. The first one is a book falls off a table and free falls to the ground. What is the work done? Here, what is happening? The book is falling freely under the force of gravity. Therefore, there is some work done on the object, on the book by the gravity. Here, the work is done on the object by the gravity because the book is freely falling under the influence of gravity. Okay. Now, let us see another example. A 10 Newton force is applied to push a block across a friction-free surface for a displacement of 5 meters to the right. Okay, see, this is the example. Here the block is there. The angle between the force and displacement is 0 because a 10 Newton force is applied to push a block across a friction-free surface for a displacement of 5 meters to the right. So the angle is 0. Okay, so what is the work done? Work here, the work done is equal to W is equal to force into displacement. This is 10 newtons dot 5 meters times cos 0 degrees gives 50 joules of work. Okay, now let us see how the angle affects the work done. Here he is pushing 100 newtons and then 5 meters. We already, this is 10 newtons. Here is another example, 100 newtons, 5 meters. So in the diagram A, for A, the answer is 100, F is equal to 100 newtons. And then the displacement is 5 meters. Therefore, W is equal to theta. Here theta is equal to 0. You are seeing, theta is equal to 0. Therefore, cos 100 times 5 times cos 0 is equal to 500 joules. The next bit is theta is equal to 30 degrees. So what happens here? Let us calculate in the B. W is equal to F is equal to 100, same value force, same displacement. But theta is equal to 30 degrees. Therefore, W is equal to 100 times 5 times cos 30. So we know cos 30 is equal to 0.8660. So what is the value? 0.8660 times 500. Okay. What is the value we get? We get 433 joules. 433 joules of work done. Now, if you want to, I will give one more example. Suppose the same force, theta is equal to 45 degrees. Next, F is equal to 100 newtons. And then displacement is equal to 5 meters. And then theta is equal to 45 degrees. Then gives W is equal to 100 times 5 times cos 45. Cos 45 is equal to 0.7071. And then this will become 0.7071 times 500 is equal to 353.55 joules. Okay, suppose if you are applying a force, I will show you that also for you. Suppose if the force applied is in the perpendicular direction. This is the object. Okay, and then the force is applied in the perpendicular direction, in this direction. And then the object moves in this direction. Then the direction of motion of the object is like this. This is the direction of motion. And then now the force is applied in this direction. And then the angle is, therefore here you are seeing theta is equal to 90 degrees. Therefore, in this case, F is equal to 100 newtons. Okay. And then D is equal to 5 meters. And then theta is equal to 90 degrees. And therefore, W is equal to cos 90 is equal to 100 times 5 times cos 90. Cos 90 is equal to 0. Therefore, work done is equal to 0. So now you must have understood the factors affecting the work done. One is the force, another one is the displacement, and the third one is angle. Okay. Now let us see another example where the work, here I told you 90 degrees will be 0. I give few more examples. Here if you see, this fellow is holding the bar constant. That means he is applying the force, but there is no displacement. So the work done is equal to 0. W is equal to 0 because D is equal to 0. Even though he is applying the force, because the object is not moving at all. Here, a teacher applies a force to a wall and becomes exhausted. Here also, the displacement is equal to 0. Even though the teacher is applying the force, the displacement is equal to 0. Therefore, the work done is equal to 0. Okay, but here you see the applied force. What is the applied force? An approximately 2 kg object is sliding at constant speed across a friction-free surface for a displacement of 5 meters to the right. Here, this is a tricky question because he is, instead of saying no force is acting on the object, he is saying that at constant speed, the object is sliding at a constant speed across a friction-free surface. That means no frictional forces are acting. If the frictional forces are acting, then the work is done by the frictional forces on the object. But here that is not there. And then the applied force is zero because it's the constant speed. And now, according to Newton's second law, if an object, unless otherwise an external force acts on an object, the object moves with a constant speed. That is why here the applied force F is equal to 0. Therefore, even though here the displacement is 5 meters, the work done is equal to 0 joules. Okay. And one more concept here. You see, when the work done is here, I told you, here you see this one. Here, the waiter is holding the tray and then walking. Okay. So the displacement and then applied force are perpendicular to each other. Therefore, again, the work done is equal to 0 because F is equal to F and D, the angle theta is equal to 90 degrees. Angle between F and D is 90 degrees because the waiter is walking across the floor, but the force is acting upwards. Same is the case here. This lady is holding the suitcase and then walking across the ground, wherever it may be, airport or wherever it may be. So the angle theta is equal to 90 degrees. Therefore, the work done is equal to 0. Okay, in both the cases, work done is equal to, in all these cases, the work done is equal to 0. So the amount of work done depends on 3 factors: the magnitude of the force, the displacement, and also the angle between the force and displacement. Okay, here is a tricky question where the object is on a ramp and then the force is in this direction and displacement is in this direction, and then the angle of the ramp, this ramp, is 45 degrees. What will be the work done? If you want, I give the values also. Suppose F is equal to 100 newtons, and then displacement is equal to 5 meters, same 5 meters. And then here the ramp angle is 45 degrees. Then what is the work done? Any guess? Correct. Work done is equal to, theta is equal to here 0 degrees. Okay, not 45 degrees because the force and displacement are in the same direction. Theta is equal to 0 degrees. So work done is equal to 500 joules. Not the, you should not take the 45 degrees because this is the ramp angle. Ramp angle will not come into picture here because the force is already given to you and then displacement is given known to you. And then, so you have to directly calculate the work done. On this concept, I did a problem and then I will keep that link in the end card. You can check that one also for your understanding, better understanding of the concept. Okay. And then I give one more example to you. Which force does the most work? Here you see 3 forces are acting at 3 different angles. Here 10 Newton force at an angle of 90 degrees. So the work done is equal to 0. Am I right? And then here 8 Newton force at 60 degrees. So the work done will be 4 joules. And then here 6 Newton force along the same directions. Therefore, it will be 6. So the 6 Newton force does the maximum work. I hope this concept understood. Okay. Now, so you have seen that what are the, when we say that work is done, and then when the work will be, here in all these cases, the work done is positive. Okay. And then when the work done is negative, when work done is equal to 0, that also I said. Now, when is the work done will be negative? In our day-to-day life, we will not say that work done is negative. We can, there may be work done is equal to 0, but now, for example, I am giving a lecture to you. Okay, I am teaching because there is no movement in my body. That means I am sitting in a chair and then giving the lecture. So the work done will be 0. Okay, so these are all the examples of work done is equal to 0 and then work done positive. Okay, now when the work done will be negative? There are cases where the work done will be negative. Suppose if the object moves in this, I show you with a diagram. Okay, so here is the block, and then the block moves in this direction. The direction of motion of the block is along this. Okay. Oh yeah. Just a moment. I will draw the line. This is the direction of motion of the object. Okay. This is the direction of displacement. Now, suppose the frictional forces are acting. How the friction acts? Because the object is moving in this direction, the friction acts in this direction. Am I right? This is the direction of the friction. Now, what is the work done by the friction? The work done by the friction on the object will be negative. Now, let us see, here is the example. A 10 Newton frictional force slows a moving object to a stop after a displacement of 5 meters to the right. Here, the displacement is given as 5 meters. And then the frictional force is given as 10 newtons. Therefore, the work done by the frictional force on the object is theta. Here, theta is equal to 180 degrees. Am I right? Because the object is moving in this direction, force is in this direction. So that theta is equal to this one. Here, suppose if I draw the force line. This is the force. 10 Newton force. Okay. F friction is equal to 10 newtons. And this is in this direction. So this is 180 degrees. Therefore, W is equal to F dot D cos theta. I write like this. Okay. So this is equal to 10 into 5 into cos 180. You know, cos 180 is equal to minus 1. So therefore, it will be 500 minus 5, minus 50, minus 50 joules. Okay. Understood. So this is all about the work done. Okay. Work done may be positive, work done may be 0, work done may be negative, depending on the angle. Okay. Here is another example. A drag racer is slowed by a parachute. What is the sign of the work done? Here, the drag racer is moving in the forward direction, and then the parachute is dragging the drag racer backwards. So the work done by the parachute is negative. Okay. So here I will write negative. In this work, the only confusing factor is angle. If you know how to identify the angle between the force and displacement, then the concept will be very easy for you. Just go through it again and then try to solve few problems, numerical problems. Then it will be easy for you. Okay. I hope this helps. Thank you. Bye-bye.